First question. If Q is equal to T square plus 4T plus 3, find the instantaneous current at T is equal to 3 seconds and average current from T is equal to 0 to T is equal to 2 seconds. So we have to find, this is given to us to find. Why am I writing? मुझे पता है बच्चे कर लेंगे, क्यों लिख रही हूँ?
सीबीएसई के तरीके से
अटेम्प्ट कैसे करोगे?
हाँ
ठीक है, नंबर 1 प्रज्ञा आप तो जरूर देखना। हाँ तो भी मैं बोल रही हूँ, बस आप लिख देखो। ठीक है, इंस्टेंटेनियस करंट एट टी इज इक्वल टू 3। नंबर 2 एवरेज करंट, बस यही बात है, ये तभी मैंने बोला, आप देखो टी इज इक्वल टू 0 टू टी इज इक्वल टू 2 सेकेंड। ओके, solution. How do we find instantaneous current? Instantaneous current is dq by dt. So let's differentiate this. T square plus 4t plus 3. Now we will write 2t plus 4. So we have to find instantaneous current at t is equal to 3. This is 2 into 3 plus 4. 6 plus 4, 10 ampere. ठीक है, सेकेंड पार्ट, स्टेप्स देखो। एवरेज करंट is delta Q by delta T. So Q at T is equal to 2 minus Q at T is equal to 0 divided by 2 minus 0. So find the values first. Q at T is equal to 2 is 2 square plus 4 into 2 plus 3. 4 plus 8 है ना, 4 to the 8 plus 3 11 15 ampere, and charge at T is equal to 0 is 2, it's 0 square. Zero square plus 4 into 0 plus 3 coulomb. मैं आपके क्वेश्चन का डाउट का आंसर दूंगी अभी, थोड़ी देर रुक के, पहले कंप्लीट होने दो। 15 minus 3 upon 2, it's 12 by 2 6 ampere. इसको अंडरलाइन, ठीक है, and underline this as well. You can also, you know, enclose your answers in the box. Drift speed of the electrons when 1 ampere, this is I, of current exists in a copper wire of cross section A is given. The number of free electrons in 1 centimeter cube of copper is this. This is number density. How do we relate I, N, A and VD?
I is equals to NE VD.
I is
VD
equal,
to I की term में लिखते हैं.
yes, I is equal to A, N, E, VD. So we can write VD as drift velocity as I upon A, N, E. Now we'll put the values here. It's 1 ampere. See, area is in 2 millimeter square. So first we need to convert this into meter square. Number density आपका है 8.5 into 10 raised power 22 per meter centimeter cube. First convert this into meter cube. So it's 8.5 into 1 meter is 100 centimeter, है ना? 1 meter is 100 centimeter. So 1 meter cube is 10 power 6 centimeter cube. So ये आ जाएगा 10 की power 28 per centimeter cube. Now solve this. A is 2 millimeter squared. It's 2 into 10 power minus 6. Number density is 8.5 into 10 raised to the power 28. And this is charge on one electron. It is 1.6 in 10 power minus 90. Have you got the answer? Lavanya?
No, ma'am.
It's 3.6 into 10 raised to the power minus 5. Are you getting the same answer? Meter per second. A potential difference of 200 volt is applied across the ends of a conductor of resistance 50 ohm. Calculate the number of free electrons flowing through it in 1 second. I don't know. Charge on each electron is 1.6 in 10 power minus 19. बेटा भी देखना पड़ेगा. You and I don't know. This is what we have to find out. N. Okay. So first find I. V is equal to IR होता है.
हाँ तो I is equals to V by R आ जाएगा.
This implies I is equal to V by R. 200 by 50. It's 4 ampere. And I is Q by T. है ना? Therefore, Q is equal to IT. So 4 into 1, it's 4 coulomb. Q is equal to NE होता है. This implies N is equal to Q by E. Now put the values. It's 4 upon 1.6 into 10 raised to the power minus 90. Hmm. 2.5 in 10 power 19 is the answer. Number of free electrons. बेटा minus 19 ऊपर जाएगा. ऊपर जाके प्लस हो जाएगा ना. ये number of free electrons आ गए. ठीक है, easy था. Find the value of resistance of the resistor. Resistance find करो. We have IV graph. How do we get resistance from IV graph? We get 1 by R. 1 by R. Slope of IV graph gives 1 by R. It's I2 minus I1 upon V2 minus V1. Right? Steps like this one. Consider any 2 points here. Let's consider this point and this point. So it's 0.3 minus 0.2. And in the denominator, we have 3 minus 1. So it's 0.1. This implies no. R is equal to 1 upon 0.1. 10. Three resistors, 1 ohm, 2 ohm, and 3 ohm are combined in series. What is the total resistance of this combination? This is the first question. Okay, so we can easily find total resistance. Let this resistance be R1, this is R2, and this is R3, and they are connected in series. Okay, so we can write, net resistance as RS, total resistance as RS, and it is equal to R1 plus R2 plus R3. So we'll simply add these resistors to get the net resistance. 1 ohm plus 2 ohm plus 3 ohm, and this is we'll get 6 ohm. So this is the total resistance of the combination. This was easy. Okay. Second, if the combination is connected to a battery of EMF 12 volts. So this is connected to a battery of EMF 12 volts and a negligible internal resistance. So we are assuming R, small r to be 0. Obtain the potential drop across each resistor. In series combination, we have different potential drop across each resistor and current is same. है ना? current across each resistor is same while potential difference is different. So potential drop is different. So let V1 be the potential drop across this resistor, V2 be the potential drop across this, and V3 be the potential drop across this resistor. Okay, so we can easily find the potential drop across each resistor. कैसे find करेंगे? कैसे find करेंगे? Potential drop across resistor 1 is V1. It is equal to IR1 because current is same but value of resistance is different. And current, we have to find out current for this. How will we find net current? So we need to find current first because we know the value of R1 and we do not know the value of this I and V1 both. We need at least two variables, right, to find the third one. So current, how will you find current? Current is the potential drop, net potential 12 upon RS is 6. RS resistance of series combination. The net resistance is 6 ohm. ठीक है, तो we'll simply divide these two. So 12 upon 6, it is 2. 2 ampere is the current. 2 ampere is the current which is flowing through the circuit. Okay, so I is 2 ampere. So now we will put the values here. So I is 2 and R1 is given, it is 1 ohm. So it's 2 volts. So 2 volt is the potential drop across first resistor. Similarly, we can find potential drop across second resistor. It's IR2. Again, we'll put the values. It's 2 multiply by R2 is 2 ohm. So it is 4 volts. Okay, and we potential drop across third resistor is IR3. Current is 2 ampere. Resistance is R3 is 3. Okay, so this is 6 volt. So potential drop across each resistor we have found out this way. So when you add these potential drop, तो जो आप इसको V1, V2 और V3 को ऐड करते हो, है ना? तो आपको क्या मिलता है? You get 2 volt plus 4 volt plus 6 volt. You get 12 volts then. The same value that we have here. V1 plus V2 plus V3 is B. Three resistors, 2 ohm. So R1 is 2 ohm, R2 is 4 ohm, and R3 is 5 ohm. They are combined in parallel. What is the total resistance of the combination? So this can be done easily. Yes. How do we find the net resistance in parallel combination? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, now we will put the values here. R1 is 2, R2 is 4, and R3 is 5. Take the LCM, but LCM will get 20. So it's 10 plus 5 plus 4. It's 19 by 20 we are getting. Hai na? So RP is 20 by 19. 20 by 19 is 1.0526. 1.0526. This is the net resistance. Next question, if the combination is connected to a battery of EMF 20 volts, so this is 20 volts and negligible internal resistance. So R is small r is 0. Find the current through each resistor. So if I1 current is flowing through first resistor, please find the current through each resistor. So we have to find I1, I2 and I3 and the total current drawn from the battery. So what we have to find is, in this second part, we have to find the net current and current through each branch. Okay. In parallel combination, potential drop across each resistor is same and current is different. So V is same for each branch. So V is 20 volts for each branch. Yes. Everywhere V value of V is 20 volts. R is given, V is given, so we can easily find current through each branch. Okay. Now because we know the value of net resistance, we can find total current. How will you find total current? V is equal to IRP. Yes, this implies I is equal to V upon RP. Put the values. Have you got the answer? You haven't done. Okay. Okay, V is 20 and RP is, this is 20 by 19. है ना? So क्या value आ रही है बेटा? it's 19 एम्पियर. ठीक है, तो ये आपका आ गया V, sorry I आ गया. Now we will find I1. So current through first branch is V by R1. अब आपकी resistor की value you will change.
10
Okay,
एम्पियर
है ना? So it's 20 and R1 is 2. So current through first branch is 10 ampere. Similarly, we can find current through second branch. It's V by R2. V is 20 and R2 is 4. It's 5 ampere. And current through third branch is V by R3. 20 upon 5. It's 4 ampere. Okay. So when you add this 10 ampere, 5 ampere and 4 ampere, you get the net current, which is 19. ठीक है, ऐसे आपका सेम ही आता है. A 4 ohm non-insulated resistance wire is bent in the middle by 180 degree and both the hulls are twisted with each other. What will be its new resistance? So we have a wire. Yes. And it is twisted. This wire is bent in the middle by 180 degree. 180 degree means? And both the hulls are twisted with each other. Twisted with each other. मतलब लेंथ हमने इसकी ऐसे ट्विस्ट कर दी है. हाँ, we have decreased the length and area of cross section is increased. ठीक है. So what will be its new resistance? So let R be the, or we can say R ले सकते हैं, 2 R ले सकते हैं, it's your choice. So let R be the resistance of this wire. Now, what will be the new resistance? See, when we twist the wire like this, then we are placing the wire parallel to each other. If we are assuming that wire का जो इसमें resistance per unit length to be constant, okay, we are assuming resistance per unit length to be constant. कि आपका जो sigma, which is resistance per unit length है, length of the wire is L, it is constant. ठीक है, if resistance per unit length is constant, then everywhere we have uniform resistance. ठीक है, so if this wire is of resistance R, then half of this wire has resistance R by 2 and this half has also R by 2. Yes, net resistance is R, length of the wire is L. So if length is reduced to half, because resistance and length, they are directly related. So if we are decreasing the length to half, then resistance will also decrease to half. And now we can find the net resistance. We can assume this as the parallel combination of two resistors, which are like this, connected like this. In parallel, this is R by 2 and this is R by 2. So we can easily find the new resistance. Have you got the answer? Net resistance is how do we find when we have parallel combination? Let this be R1, this be R2. So we simply write R1 R2 upon R1 plus R2. Okay, so it's R by 2 into R by 2 divided by R by 2 plus R by 2. अच्छा, वैसे भी when we have equal resistance and they are connected in parallel, then we magnitude half कर देते हैं, है ना. दोनों R by 2 है, तो अगर parallel में है तो जो net resistance होगा वो R by 4 होगा, उसका magnitude हम half करते हैं, है ना. इसमें इसका कुछ वैल्यू भी दिया हुआ था क्या? अच्छा, 4 ओम दिया हुआ था ना. तो अब net resistance, put the value of R here, it's 4 upon 4. Answer is 1 ohm. N resistors है, each of resistance are. You all can do, I guess. It's an easy question, no? हो जाएगा? So we have N resistors. ठीक है, each of resistance are. Value of each resistor is R. So we have N number of resistors. we have to combine them to get the maximum effective resistance, number one, and minimum effective resistance. How do we get maximum effective resistance? When we connect resistors in series, we get maximum effective. Okay, so we'll simply add these resistors. Because we have n number of resistors, we'll add R n times. What will we get? तो हम R को n times ऐड करते हैं तो क्या मिलता है? 5 को 2 times ऐड करते हैं तो 5 into 2 करते हैं, 3 times करते हैं तो 5 into 3 करते हैं. NR हो जाएगा ना? R को n times ऐड करोगे तो you'll get NR. So this is the maximum effective resistance. Okay, and how do we get minimum resistance? When we connect resistors in parallel, we get minimum effective resistance. Okay. So for minimum resistance, we'll connect resistors in parallel, all the resistors in parallel to get minimum resistance. So it's 1 upon R plus 1 upon R plus 1 upon R again n times. Okay, again, what should I write? N by R because of n times add कर रहे हो, है ना? जैसे आपके पास 1 upon 2 plus 1 upon 2 अगर आप 3 times add कर दो तो you get 3 by 2, है ना? तो ऐसे आप 1 by R n times add करो तो you'll get n by R. So R minimum is, take the reciprocal again, it's R by n. Okay, so this is the minimum resistance and this is the maximum resistance, effective resistance. Next question is, what is the ratio of the maximum to minimum resistance? Now we have to find the ratio of R max to R min. Maximum to minimum resistance का ratio find कर. So maximum resistance is NR and minimum resistance is R by N. So what will we get? N square. So ratio is N square is to 1. We are given the resistances of 1 ohm, 2 ohm, 3 ohm. How will resistances be combined? How will we combine them to get an equivalent resistance of this and this? We have 3 resistors. So R1 is 1 ohm, R2 is 2 ohm, and R3 is 3 ohm. How will we combine them to get an equivalent resistance of 11 by 3 ohm, 11 by 5 ohm, 6 ohm, and 6 by 11? 6 तब होगा जब सीरीज में होगा. तो एक तो तरीका ये है कि we will simply place these resistors in series, है ना? So when we place these resistors in series, we get the effective resistance as ये R1 है, ये R2 है, R3 है. So you'll get the effective resistance as RS. It is equal to 1 ohm, 2 ohm, and 3 ohm. It is 6 ohm. So when all the resistors are connected in series, we get 6 ohm. थर्ड पार्ट हो गया. ओके, अब और बताओ. आप जैसे बोलोगे मैं वैसे ही फॉलो करूं. सबको पैरेलल ले ले, देखिए क्या आता है. Let's connect all the resistors in parallel. If we connect all the 3 resistors in parallel, then we get effective resistance as RP. It's 1 upon 1 plus 1 upon 2 plus 1 upon 3. LCM is 6. 6 plus 2 3s are 6. 3 2s are 6. 9. 11 by 6. Okay. So this implies RP is equal to 6 by 11. Which part we have covered? We have covered 4th part. So when all the resistors are connected in parallel, then we get this resistance. ये भी हो गया, ये भी हो गया. ठीक है. Next, what if I connect one resistor in series and 2 in parallel? कोई भी randomly you can take. अच्छा, 1 and क्या करोगे? 1 और 2 और 2 और 3 को पैरेलल में करेंगे तो let's see. ठीक है, तो अब यहाँ पे we get the effective resistance as 1 plus, because when the two resistors are in parallel, then we write 2 into 3. upon 2 plus 3. We write like this. Okay. So 1 plus 3 to the 6 and 3 plus 2, 5. We get 11 by 5. ठीक है जी. चलो भवेश ने जैसे बोला हमने वैसे फॉलो किया. सेकंड पार्ट हमारा हो गया. अब भवेश नेक्स्ट बताओ. हाँ जी. 1 और 3 को पैरेलल में कर लेते हैं. ठीक है. कहाँ करें? रब कर दें ऊपर से. ऐसा ऐसा क्वेश्चंस ना आपके 10th में भी था, याद है ना? आपने किया हुआ इलेक्ट्रिसिटी चैप्टर में. यू हैव डन 1 ohm एंड 2 ohm ले रहे हो ना आप यहाँ पे, और यहाँ 3 ohm लो. ठीक है. तो यू विल गेट 3 plus 1 into 2 upon 1 plus 2. So it's 3 plus 2 upon 3. 9 plus 2 by 3. It's 11 by 3. 11 by 3 ohm. This is how we will connect the resistors to get this value. Find the equivalent resistance of the network. See, all these resistors are in series or in
Series. Series
all
में
the resistors are in series. So what is the equivalent resistance?
5 4.
1, 2, 3, 4, 5. It's 5 R. क्या है आपका कि you have a wire and you connected all the resistors. आपने उसको बस इस पैटर्न में you have placed the resistors like this. But when you stretch the ends, है ना, so you'll get all the resistors in series. See, when we have a network like this, which is an infinite network, ठीक है, तो वहां पे हमें पता नहीं है कि कहाँ तक जा रहा है ये, right? Usually, if we have 4 resistors, then we know that we take 3 resistors in series and 1 in parallel and we solve easily. और diagonally निकालोगे तो 2 इधर वाले series, इधर वाले series and the combination is in parallel. This is how we solve, है ना? But here it is, an infinite network. So we don't know कि कितने resistors हैं, कितनी values आएंगी, तो we do not know the exact number. अब हम क्या करते हैं इसमें? We consider this part. We consider this part of this combination, this part, resistance, equivalent resistance of this portion as X. Let the equivalent resistance of this portion be X. Okay? Clear? इतना आ गया समझ? Shrishi, please stop writing. एक बार सुन लो, आता है? So equivalent resistance of this portion be X. So अगर आप जैसे बहुत बड़ा नंबर है, अगर उसमें if you are adding a small number, then you get the same number, nearly equal to same करते हैं ना हम. If we write 0.009, then we can write this as nearly equal to 0.01. कर सकते हैं ना ऐसे. या if you have a very big number and we are adding 1 to it, then you can write nearly equal to 10 to the power 5. We do like this, है ना? तो वही चीज कॉन्सेप्ट को हमने यहाँ पे अप्लाई करना है. We will assume that our equivalent resistance of the network is X. So let equivalent resistance of the network be X. ठीक है. तो अब ये जो X है और equivalent resistance को हम X assume कर सकते हैं because हमने सिर्फ थोड़ी सी resistors छोड़ी है. ठीक है. तो अब अगर आप इसको redraw करोगे, then what will you get? We have 1 ohm here, 1 ohm here, ठीक है, 1 ohm here, and in place of this resistor, all these resistors, we are placing one resistor, which is X. ठीक है. तो ये 1 ohm है, ये भी 1 ohm है, and ये भी 1 ohm. And equivalent resistance is also X. ठीक है. तो अब क्या है? We'll consider these two in parallel. These are in parallel. And इसका जब पैरेलल निकालोगे तो इसका जो इफेक्टिव रेजिस्टेंस आएगा वो क्या आएगा? 1 into X upon 1 plus X. So we can write X upon 1 X plus 1. Now these three resistors are in series, है ना? So we can write our R equivalent as R equivalent as 1 plus 1 plus x upon x plus 1. This R equivalent is nothing but x. X is equal to 2 plus x upon x plus 1. Okay? X is equal to, now you can solve for x. You'll get a quadratic equation. Karo. So you'll get 2 x plus 1. Sneha, you were absent on that day. हमने ये क्वेश्चन किया हुआ है. आप भी absent थे पीछे boys? Sunday को absent है ना? X is equal to 2 into x plus 1 plus x upon x plus 1. So x into x plus 1, and here we have 2x plus 2 plus x. This is x square plus x minus 3x minus 2 is equal to 0. X square minus 2x minus 2 is equal to 0. Are you getting the same equation? Now we will solve this equation for x. We know how to solve the quadratic equation minus b plus minus under the root of b square minus 4ac upon 2a. This is how we write, है ना? We know the formula. Quadratic formula पता है ना? So we'll use that formula. Minus means minus of minus 2 plus minus b square is minus 2 square minus 4a and c is minus 2 upon 2. And if we assume this as ax square plus bx plus c equals to 0, then we can find x as minus b plus minus under the root of b square minus 4ac upon 2. We've used this formula here. Okay, so minus minus plus 2 plus minus under the root of 4 minus minus plus 4 to the 8 upon 2. So it's 2 plus minus 12. We're getting 12. 12 is 2 root 3 upon 2. So we will get this 1 plus minus root 3. See, value of x cannot be negative. Root 3 is 1.73. Value of root 3 is 1.732. We cannot subtract this number from 1 because we get a negative number. So we'll add this. Okay. So the value of x is 2.732 ohm because this is the value of equivalent resistance. Okay. Now we have to find current. Current find करना है. How will you find current?
V is equals to IR लगा देंगे.
See, current के लिए we need to find net resistance first. This is the resistance which is connected like this, and we have internal resistance also. It's 0.5 ohm. है ना? So it is 12 upon the resistance that we have got here are equivalent plus the
Plus R.
small resistance R. Let this be internal small r. Okay. So it's 12. R equivalent is 2.732 plus small r is 0.5. Now you can solve for I. 1 plus है ना? 1 भी तो ऐड करोगे. हाँ जी बताओ क्या आ रहा है आंसर? 12 upon 3.23 ampere, and this is equal to 3.72 ampere. Length of the wire is given, it is 15 meter. Area of cross section is given, it is 6 into 10 raised to the power minus 7 meter square. Resistance is given, it is 5 ohm. We have to find resistivity of the material. Use the relation R is equal to rho L by A. So this implies rho is equal to R A by L. Now put the values here. Resistance is 5. Area of cross section is given 6 into 10 to the power minus 7. Length is given, it is 15. Answer is 5 ones are 5, 5 3s are 15, 3 ones are 3, 3 2s are 6. It is 2 into 10 raised to the power minus 7. What is the unit? Ohm meter is the unit. First, write the quantities which are given to you. 27.5 degrees Celsius is 2.1 ohm, and resistance at 100 degrees Celsius is 2.7 ohm. We have to find alpha, temperature coefficient of resistivity. बताओ भाई कैसे करेंगे? It's you can use a relation. Yes, children who are taking class online, they can also respond. Arshia,
Yes, ma'am.
बताओ बेटा, which formula you can use here?
मैम मुझे नहीं पता.
Sorry, please come again. नहीं पता.
नहीं मैम.
RT is equal to
मैम ये
R
वो क्लास जो छोटी
plus
थी वो है ना.
alpha T we had done na. We have used this relation. At 27 degrees Celsius, we can write 27.5 is equal to R naught. R naught is the resistance at 0 degrees Celsius, and 1 plus alpha. This is the rise in temperature. It's 27.5 degrees Celsius. I'll write 27.5 alpha. And similarly, we can write for R100. R100 is equal to R naught 1 plus 100 alpha. Change in temperature, we are considering 0 degrees Celsius. No? Delta T होता है. So 0 degrees Celsius to 27.5 degrees Celsius करोगे तो you will get 27.5 only. Now divide these two. Divide these two. 1 divided by 2 gives R 27.5 upon R100 is equal to R naught 1 plus 27.5 alpha upon R naught 1 plus 100 alpha. R naught से R naught cancel हो जाएगा. Now put the values here. R 27.5 is 2.1 and R100 is 22.7 is equal to 1 plus 27.5 alpha upon 1 plus 100 alpha. So this is 3 sevens are 21, 3 nines are 27, 7 by 9. Okay, now cross multiply. We will get 7. In the bracket, we have 1 plus 100 alpha is equal to 9. 1 plus 27.5 alpha. This is 7 plus 700 alpha is equal to 9 plus multiply करके बताओ क्या आ रहा है 247.5 alpha. Okay. 700 alpha minus 247.5 alpha is equal to 2. Subtract करके बताओ क्या आ रहा है 452.5 alpha is equal to 2. This implies alpha is equal to 2 divided by 452.5. Divide करो. Give me the answer. Zero point 0.0419 per degree Celsius. At room temperature, 27 degrees Celsius is the room temperature. The resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm, given that temperature coefficient of the material of the resistor is this? Try this question. At 27 degrees Celsius, how do we write resistance? If temperature is given, we write like this, na R27. This is how we write. This represents temperature. So it is 100 ohm. What is the temperature of the element? Let temperature be T. At temperature T, let's say at temperature T, the resistance is found to be 117 ohm. Given that the temperature coefficient of the material of resistor, temperature coefficient of the material of resistor is temperature coefficient of resistance is alpha. It is equal to 1.7 into 10 raised to the power minus 4 per degree Celsius. Resistance at temperature T is resistance at 0 degree Celsius 1 plus alpha T, where T is the temperature, or we can say that it is rise in temperature from 0 degree Celsius to T degree Celsius. This is the temperature. But if we say that from T1 degree Celsius to T2 degree Celsius, we want to write the same relation, then how do we write? From T1 to T2, we write R. Tell me. How do we write?
R. इसके लिए लिखना
T1 to T2, how do we write?
RT is equals to R naught 1 plus alpha T2 minus.
Yes, RT is equal to R naught we take when we take 0 degree Celsius. But if we take RT, then R1 and R2, then if we assume that we have two different temperatures, T1 and T2 degree Celsius, then how do we write? Let R1 be the resistance at T1 degree Celsius and R2 be the resistance at T2 degree Celsius. Then how do we write? R1 is the resistance. R1 is the resistance at T1 degree Celsius and R2 is the resistance at T2 degree Celsius. Then how do we write? बताओ? कैसे लिखते हैं? We write R2 minus R1 as alpha R1 T2 minus T1. This is how we write if different temperatures are given, and at different temperatures we have different value of resistance. Yes, at different temperatures we have different value of resistance, then we write like this. And if we have 0 degree Celsius and T degree Celsius, then we don't write 0 because it's understood that T minus 0 is T. So no need to write. Okay. Now we have to find T. So which relation should we use? We'll use this relation. Alpha is equal to this. And alpha is given. So alpha is equal to, we can write R2 minus R1 divided by R1 T2 minus T1. Yes, but we are going to move this.
Maths में 2 point form की तरह होता है, बस उसमें ये फर्क है R1 हम लिखते हैं by x.
Yes. So T2 minus T1 can be written as R2 minus R1 divided by alpha R1. Okay, now we can consider this R2 as resistance at temperature T. So we can write this as T minus 27. Okay, 27 degrees Celsius is given. T minus 27 degrees Celsius is equal to R2 is the resistance at temperature T and R1 is the resistance at temperature 27 degrees Celsius divided by alpha, and this is the resistance at temperature 27 degrees Celsius. Initial we can see. Okay, initial is R1. No? 1 we are denoting for initial and 2 for final. Okay. Now just put the values here. So therefore T minus 27 is equal to resistance at temperature T is 117 Resistance at 27 degrees Celsius is 100 ohm divided by alpha. Value of alpha is 1.7 into 10 raised to the power minus 4. And value of this R27 is 100. Okay, just put the values here. What will you get now? This 117 minus 100 is 17. And in the denominator, we have 1.7 into 10 raised to the power minus 2. Okay, this is equal to T minus 27. So therefore, T minus 27 is equal to, we can solve this easily. Anna, what will we get? 1000? We'll get 1000 because when you write this, now you can write like this. So into 10 raised to the power 2. So it is 1000. So this implies T is equal to 1000 plus 27 plus. So it's 1027 degrees Celsius. This is the temperature. At this temperature, what is the resistance? 117. At 1027 degrees Celsius, temperature resistance is 117 ohm. And at 27 degrees Celsius, resistance is 100 ohm. So you can see when we increase the temperature, resistance also increases for a conductor. And because this is a heating element, so it might be an alloy, so there is a small change in resistance. And if this is a conductor, then there would be greater change. For aluminium first. Density of aluminium, relative density of aluminium is given. Let's write 1 for aluminium and 2 for copper. So for aluminium, we are writing. Relative density is 2.7. Resistivity of aluminium is given. It is 3 into 10 power minus 8 ohm meter. Okay. Okay, calculations. Let's take mass of aluminium wire as M1 and its area of cross section as A1. Now for copper, relative density is 8.9. Resistivity of copper is 1.72 into 10 power minus 8 ohm meter. Mass of copper is M2. Area of cross section of copper is A2. Okay. So we can write, the value of resistance. Let the resistance be R1 and resistance be R2, and R1 and R2 are equal. It is given. So we'll do this question in steps. So in step 1, we are going to write resistance for both. So resistance for aluminium first. R1 is equal to rho. L is same for both. It's L upon A1. Let this be 1. For copper, R2 is equal to L upon A2. Let this be 2. R1 and R2 are equal. Their resistance is given for resistance equal. So equate them, you'll get rho AL L upon A1 is equal to rho Cu L upon A2. On equating these two, you'll get this. Now you can find the ratio A1 by A2. This implies A1 by A2 is equal to L cancel ho jayenge. A1 by A2 is equal to rho L AL, resistivity of aluminium divided by resistivity of copper. Let this be 3. Garida, Mayank. Now step 2. This is step 1. In step 2, see, how do we write mass? Mass is volume into density, right? No? And volume is area into length. Area of cross section into length into density, right? Yes? So now we will write for aluminium, we'll write mass first. For aluminium, M1 is area of cross section of aluminium is A1, length is L, and density is D1. Yes. Similarly, we can write for copper.
A2 and D2.
For copper, we will write its M2 is equal to area of cross section is A2, L, and D2. Now divide these two. This implies M1 by M2 is equal to A1 L D1 upon A2 L D2. L cancel. We know A1 by A2 is this ratio of resistivity. So we'll write this here, rho AL upon rho CU into D1 by D2. Now put the values. We know the values of all these quantities. Yes, it's 2.63 into 10 raised to the power minus 8 divided by resistivity of copper is 1.72 into 10 raised to the power minus 8 into D1 is 2.7 and D2 is 8.9. What answer you're getting? Have you solved this? It's 0.4638. No, this is the answer. 0.4638. So M1 by M2 is less than 1. This implies M1 is less than M2. So aluminium is lighter than copper. Aluminium is lighter than copper. And because aluminium is lighter, it is preferred for overhead cables over copper. Because it is lighter and therefore it is preferred for overhead power cables. L. So length of each wire is L. Length of each wire is L. The area of cross section is different. First wire has area of cross section A1. Second wire has area of cross section A2. And their resistivity is also different. Resistivity of first wire is rho1. Resistivity of second wire is rho2. And they are connected in parallel across a DC supply. Obtain an expression for the effective resistivity of this combination. So we have to find effective resistivity.
नहीं resistivity
We have different resistivity.
अरे नहीं same मुझे लगता है कि equation में आपके साथ वो है
No.
different है रो वन है
Okay. That. Right.
रो दो ही लिखा था ने
It's rho1, rho2. It's not rho1, rho1. It's rho2, rho2. Rho1, rho2. Rho1, rho2. Okay. So they have different resistivity and different area of cross section, but their lengths are equal. Because two quantities are different, so resistance will be different. Let R1 be the resistance of this wire, R2 be the resistance of the second wire. Then we can write R1 as and R2 as. See, because these two wires are connected in parallel, so our system is in parallel combination. So how do we find effective resistance in parallel combination? Yes, 1 by R is equal to 1 by R1 plus 1 by R2. Or we can write R as R1 R2 upon R1 plus R2. Okay. So what is the, you just put the values here. It's R1 is rho1 L by A1. You know how to do this? Have you done? R2 is rho2 L by A2. R1 is rho1 L by A1. Then we have a plus sign. Rho2 L by A2. Okay, now simplify this. You'll get rho1, rho2 L square. In the denominator, you have A1, A2. And here we'll have rho1 L. We can take common. So choice rho1 A2 plus rho2 A1 L common. And in the denominator again we have A1 A2. So on simplifying we get rho1 rho2 L square, and here we have rho1 A2 plus rho2 A1 L. Cancel. So we got this. This is the net resistance. Now we have to find the effective resistivity. So effective resistivity is net resistance. Effective length will take the same value, na, L only, because we are connecting these two wires in parallel. So resistance length will remain the same. There will be no change in length. Sorry. It's RA by L, because R is rho L by A. So L is, if you want to find rho, then it is RA by L. Okay. So we'll write A first. And A area of cross section is, it will increase to, है ना? It's A1 plus A2. Area of cross section will increase. And L remains the same. Yes. So this implies rho effective is equal to, put the value of R here. It's rho 1, rho 2, L, A1 plus A2 upon rho 1, rho 2, L, A1 plus A2 upon, in the bracket, and the denominator we have rho 1 A2 plus rho 2 A1 into L. LL cancel. And now we have rho 1, rho 2 A1 plus A2 divided by rho 1 A2 plus rho 2 A1. So this is the effective resistivity. Yes. Voltage is given. Write the things which are given to you first. Voltage is given, it is 230 volt. Okay. Initial conditions, initial current is given. All the quantities which are given now, first write those quantities. Initial current I1 is 3.2 ampere. And steady state current is given. Steady state current is given. It is I2, it is 2.8 ampere.
What is the ST?
And temperature coefficient of resistance is given, alpha. It is 1.7 into 10 to the power minus 4 per degree Celsius. T1 is given. T1 is 27 degrees Celsius. We have to find T2. First find R1. R1 and R2. You can find. How will you find R1? V by I1, yes. Now put the values. V is 230 and I1 is 3.2. What value you are getting? It's 71.9 ohm. Similarly, find R2. Find R2. It's V by I2. Yes. Again, put the values. 230 upon 2.8. Hanji, give me the answer. No. It's 82.14. Alpha is given, T1 is given, R1, R2 we have found out. Now use the same relation. Because alpha is equal to R2 minus R1 on R1 T2 minus T1. Use the same relation and get the value of R2 T2. T2 minus T1 is equal to R2 minus R1 upon alpha R1. Now put the values here. R2 is 82.14. R1 is 71.9. Alpha is given. Alpha is 1.7 into 10 raised to the power minus 4. And R1 is 71.9. Solve this. Answer is 837.764. Now, but we have to find the value of T2, right? So it's T2 minus 27. 27 degrees Celsius, yes? So this is 837.764. So this implies T2 is equal to 837.764 plus 27. Now give me the answer. 8. It's 864.764 degrees Celsius. Is the answer? Yes. देखो आपने उसको इंक्रीज किया ना, आपका जब ये टेम्परेचर राइज हुआ तो फिर रेजिस्टेंस इंक्रीज हो रहा है। अच्छा एक चीज नोटिस की, ये नाइक्रोम है। नाइक्रोम क्या होता है? अलॉय होता है ना, निकल एंड क्रोमियम अलॉय होता है। इसका रेजिस्टेंस देखो इतना बहुत ज्यादा मेजर डिफरेंस नहीं आया। मतलब करंट आप टेम्परेचर को कितना राइज कर रहे हो, 27 से आप 864 पे आ गए, बट आपकी रेजिस्टेंस की वैल्यू में थोड़ा सा ही चेंज आया है, बहुत मेजर चेंज नहीं है। उसमें रेजिस्टेंस इंक्रीज तो होता है बट उतना ज्यादा इंक्रीज नहीं होता जितना कंडक्टर्स में होता है। तभी हम अलॉयज यूज करते हैं, रेजिस्टेंस बॉक्स बनाते हैं तो अलॉयज के बनाते हैं ना, क्योंकि चेंज टेम्परेचर चेंज करने से बहुत ज्यादा चेंज नहीं आता रेजिस्टेंस में। अगर हम किसी मेटल के बनाएंगे तो फिर इफेक्ट जो चेंज आएगा काफी, इसलिए we use alloys. A 10-volt storage battery of negligible internal resistance is connected across a 50 ohm resistor made of alloy manganese. How much heat is produced in the resistor in 1 hour?
I swear out.
Yes.
Then for we are here.
See, a voltage is given. It's V is equal to 10 volt. Resistance is given. It's 50 ohm. Time is given. It's 1 hour. A 10 volt storage battery of negligible resistance, internal resistance is connected across a 50 ohm resistor made of alloy. How much heat energy is produced in the resistor in 1 hour? And what is the source of this energy? See, we have to find heat produced and the source of energy. Heat produced is I square RT, or we can write heat produced as V square T by R. No? Okay, now put the values here. We'll use this V square T by R because we have all the variables here. So it's V square is 10 square into T is 1 hour. 1 hour is 3600 second. 3600 second. And resistance is given, it is 50 ohm. Find H. Find the heat produced, it's 0 cancel. You'll get 7200 joule. 7200 joule. What is the source of this energy? Source of this energy? It is a battery. So what is the source of energy? The source of this energy is the chemical energy. नीचे से बेटा इसको घुमाओ इधर इधर. The source of this energy is the chemical energy. Chemical energy stored in the cell. Uh, 200 volt, 300 watt, 200 volt and 600 watt heaters are combined in series, and the combination is connected to a 200 volt DC supply. Which heater will produce more heat? Find answer. Let's consider this as, see, because this voltage is 200 volt, yes. So let's write this as V, this as V, this is P1 and this is P2. Okay, so we can find resistance of both the heaters first. resistance of the two heaters. Hmm. Have you called this?
Compared power ज्यादा होती है firstly, तो फिर actual power होती है वो secondly ज्यादा होती है.
Resistance of the two heaters. ये बंद कर दो. No, बंद कर दो. Resistance of the two heaters R1 is equal to V square by P1. 200 into 200 upon P1, power is given, it's 300. This is 400 by 3 ohm. Similarly, we can find resistance of the second heater. It's R2, V square by P2. Write formulas, write all the steps. Okay. 200 into 200, as I am writing here, on 600. So you'll get 200 by 3 ohm. Okay. Now for series combination, how do we find effective resistance? Simply add the resistance. Yes. For series combination, we add the resistance. Yes. So R1 plus R2 is 400 by 3 ohm plus 200 by 3 ohm is equal to 600 by 3 ohm, and this is 200 ohm. This is the effective resistance. We can find current because we know the supply, no? It's 200 volt DC supply. Current is V by R. R effective, yes. So V is 1 ampere aega. 200 upon 200. Current is 1 ampere. Now let's find power dissipated in the first heater. Yes. In the first heater, it's P1 is equal to I square R1. Okay. Now put the values. This is 1 square. R1 is 400 by 3.
400 by
So this
3 let me do.
400 by 3 watt. Similarly, we can find for second heater. It's P2 is equal to I square R2 again. 1 square into 200 by 3. This is 200 by 3 watt. Okay. So we can see that P1 is twice of P2. This implies P1 is greater than P2. Yes.
Reciprocated मतलब कितना है?
P1 is equal to P2, no? No, P1 is less than P2, huh? एक
वैल्यू निकाले तो P1 की ज्यादा है.
Hmm?
400 by 3 is approximately 133.3. Or 200 by 3 is 66.67. So P2 मुझे smaller लगा है. Even
Yes, तो यहाँ पे P2 smaller आ गया P1 से. Power dissipated है ना, ये question में क्या है? Which will produce more heat.
price of P2 is given.
ये power dissipate हुई है ना? Power dissipate होगी मतलब heat current बढ़ोगी.
Power consumed ज्यादा होगी मतलब
Power dissipate हुई है तो power consume किसकी ज्यादा होगी?
फिर सारे consume होगी तो फिर effective power कम होगी. हाँ तो मतलब जैसे power consume करेगा तो फिर heat कम produce होगी. कि power ज्यादा consume होगी. Power इसमें
ये I square R बेटा heat produce का ही तो है. जो H इज इक्वल टू आई स्क्वायर RT करते हो आप, और जो H होता है आप अगर कहीं आप निकालते हो तो पावर जो आपका H अपॉन T तो होता है, ये प्रोड्यूस बाय यूनिट टाइम। P1 is greater than P2. P1 is greater than P2. Formula for finding maximum current is E by R. Yes, E is given, it's 12 volt. Internal resistance is 0.4. Answer is 30 ampere. इसको क्वेश्चन में ना, इसमें हम क्या करते हैं कि अगर मैक्सिमम करंट ड्रॉ कब करेगा, आपने वो V इज इक्वल टू E माइनस आई आर किया हुआ है ना, उसमें भी पुट दिस इक्वल टू 0, तो आपका V इज इक्वल टू आई आर आता है एंड I इज द मैक्सिमम करंट। एक तो ये वाला कॉन्सेप्ट लगाते हो, सेकंड आप ये लगाते हो कि आपका जो E है I है, मतलब आपका जो E है, सॉरी, E इज इक्वल टू आई आर प्लस आई आर, ठीक है, तो I कॉमन, ब्रैकेट में R प्लस R, तो यहाँ से भी फाइंड I इज इक्वल टू आई E अपॉन R प्लस R, तो रेजिस्टेंस 0, तो आपका मैक्सिमम करंट आ जाएगा E अपॉन R। ठीक है, ये करवाया था मैंने क्लास में। A battery of EMF 10 volt and internal resistance 3 ohm. Current is given, it's 0.5 ampere. What is the resistance of the resistor and what is the terminal voltage of the battery when the circuit is closed? R and V we have to find out. How do we write? V is equal to E minus IR. Yes. Sorry.
8.1.
IR is equal to E minus IR. This implies R is equal to E upon I minus R. Now put the values here. E is 10, I is 0.5, small r is 3. We will get 20 minus 3, 17. Are you getting the same answer? Yes. Okay, and terminal potential difference is V, it's equal to IR. Put the values, I is 0.5, R is 17, it's 8.5 volt. Next question we have here is 6 lead acid type of secondary cells, each of EMF 2 volt and internal resistance 0.015 ohm are joined in series to provide a supply to a resistance of 8.5 ohm. What is the current drawn from the supply and its terminal voltage? This is part A of this question. In part B, we have a secondary cell after long use has an EMF of 1.9 volt and a large internal resistance of 380 ohm. What maximum current can be drawn from the cell? Could the cell drive the starting motor of a car? These are the two parts of the question. Yes, so we have 6 lead acid type of secondary cells. Okay, let's draw 6 cells and the internal resistances of each cell is given. So we can draw like this. This is one cell and this represents its internal resistance. This is second cell and this represents its internal resistance. Third cell, internal resistance. Fourth cell, and they all are in series. In series, we add the EMFs, we add the internal resistances. Yes. So this forms one cell and this resistance represents the internal resistance of the cell. Okay. So EMF is given, EMF is 2 volt and internal resistance of the cell is given. It is 0.015 ohm. Okay. And they are joined in series. to provide a supply to a resistance of 8.5 ohm. So we are just connecting this system of cells with a load resistance, and the value of this load resistance is given to you. It's 8.5 ohm. Yes. So what current is drawn from the supply? We have to find the value of current and the terminal voltage. So in the first part, we have to find current, number one, and number two, terminal voltage. How will you find? कैसे find करोगे? What is the net resistance of the system? Can you find net resistance? All resistors are in series. So we will simply add the resistors to get the net resistance. Yes. So we have 6 internal resistances you can see here. So we'll write 6 into 0.015 plus 8.5. So this is the net resistance that we'll have. Ohm. Okay. So what value you'll get? क्या किया? You done anything wrong? Its value is 8.59 ohm. Okay. 8.59 ohm. 15 6 are 90. It's a very simple calculation. 15 6 are 90 होता है ना? And EMF is 12 volt. So net resistance and net EMF you know now. So you can easily find current. How do we find current? It's E by R. Divide these two. 12 upon 8.59. On solving this, you'll get the value of current. Dekho, how will you find the nearly equal to? कैसे find करते हैं? We can consider this as, if we consider this as 12 by 8, then it is 2, it is 3, value is 1.5. Okay, but because it is not 8, it is greater than 8. Denominator is not 8, na? It is greater than 8. So आपकी जो value आएगी वो less than 1.5 आएगी, near 1.4, around 1.4 आएगी. ऐसे
1.39.
हाँ जी.
1.39.
1.39. Okay. So 1.39, or we can write this as 1.4 एम्पियर, है ना? तो थोड़ा अप्रॉक्स ले लेते हैं. तो ऐसे ना एक आइडिया लग जाता है हमें कि इसकी वैल्यू इतनी आनी चाहिए. ओके. तो जैसे आपने 12 by 8 करके, तो फिर इंस्टेड ऑफ टेकिंग इन 8.59 यू कैन डू लाइक दिस, और फिर इसकी वैल्यू 1.5 से कम आनी चाहिए, बिकॉज denominator is little greater than 8, it is 8.59, so value should be less than 1.5, that's 1.4 or 1.39. Okay. So this is how you can calculate. Now we can find terminal voltage. How do we find terminal voltage? V is equal to I R. Now put the values here. Value of I is given. We have found out, and resistance is the net resistance. It is the load resistance. Sorry, load resistance is 8.5. Okay. Load resistance is 8.5. Now multiply these two.
11.9.
Okay. So it's 11.9 volt. So this is the value of terminal voltage. Okay. So now we have found out both the values. We have found out terminal voltage and the current. Let's move to the second part of this question. In the second part of the question, we have a secondary cell after long use has an EMF of 1.9 volt. Secondary cell B part. So EMF is given, it's 1.9 volt and large internal resistance of 380 ohm. Internal resistance is 380 ohm. What maximum current can be drawn from the cell? What maximum current? How do we find maximum current? For maximum current, what do we do? For maximum current, we write EMF divided by internal resistance. Yes, this is how we find maximum current. यहाँ पे ये जो R है, this R is the, एक मिनट, we should not write like this. Instead,
तो ये दो में
please,
अलग-अलग
please,
क्वेश्चन.
let me. We should not write like this because we should write this as R dash, okay? Because this is not the net resistance. This is the load resistance. Now let the load resistance be R dash. And no. Here we'll write. So let the load resistance be R dash. This is your IR dash. And this is your net resistance. R is what? R is load resistance plus the 6 resistors, internal resistors that you have. Resistance of those 6 resistors that you have. So this is the net resistance. This R is the net resistance. When we are finding the value of I, current, then we are considering this resistance. Net resistance we are considering. So I is E upon R dash plus 6R in this case. Okay. Are so much? For terminal voltage, we are considering only load resistance. For terminal voltage, load resistance, and for current, net resistance. But if you have to find maximum current, then we only consider internal resistance. E as 1.9 in this case, and internal resistance is given, it is 380. Now you can see 19. When you take the, when you multiply 19 by 2, you get 38. No, see, it's 1 by 2. You can write like this, na? 90 upon 38 into 100. 19 ones are 19, 19 twos are 38. It's 0.5 upon 100. So what will you write? 0.005 ampere. This is the maximum current. So can we start a motor? Could the cell drive the starting motor of a car? Could the cell drive the motor of a car? No. Cell cannot, this current is very less. It's 100 ampere. So it is impossible to start. It is impossible to start motor with this current value. Okay, we cannot start a motor with this current. It's a very small current.